Dear students, let us continue inverse trigonometric functions. As already we have discussed some basic concepts of inverse trigonometric functions in our earlier videos. Let us just recall whatever the things that we have learned in the previous classes. Okay. See, sin y is equal to x will imply that y is equal to sin inverse x when x lies in the closed interval -1 to 1 and y lies in the closed interval -pi by 2 to pi by 2. Then cos y is equal to x will imply that y is equal to cos inverse x when x lies in the interval -1 to 1, closed interval -1 to 1, and y lies in the closed interval 0 to pi. So from this it is evident that for cos inverse x the domain is -1 to 1 and the range is 0 to pi. Then tan y is equal to x will imply y is equal to tan inverse x when x is any real number and y belongs to the open interval -pi by 2 to pi by 2. Okay. Then secant y is equal to x will imply that y is equal to secant inverse x when x lies in this interval -infinity to -1 union 1 to infinity. In other words, we can also write this as set of all real numbers except the open interval -1 to 1 and y lies in the interval 0 to pi, closed interval 0 to pi except pi by 2. So for secant inverse x the domain is this interval -infinity to -1 union 1 to infinity and the range is closed interval 0 to pi with the exception of pi by 2. Then cosecant y is equal to x will imply that y is equal to cosecant inverse x whenever x lies in the interval -infinity to -1 union 1 to infinity and y belongs to the closed interval -pi by 2 to pi by 2 except 0. So for cosecant inverse x, this interval, that is the set of all reals except the open interval -1 to 1 is the domain and this interval is the range. Then for cot inverse x, cot y is equal to x will imply that y equal to cot inverse x whenever x is any real number and y lies in the open interval 0 to pi. Okay. This is the basics of these 6 inverse trigonometric functions. Now let us discuss some properties of these inverse trigonometric functions. Sin inverse of sin y is equal to y if y belongs to closed interval -pi by 2 to pi by 2. Cos inverse of cos y is equal to y if y belongs to closed interval 0 to pi. Tan inverse of tan y is equal to y if y belongs to open interval -pi by 2 to pi by 2. So these are the 3 formulae you should know. Sin inverse of sin y, we can write that as y provided y lies in the closed interval -pi by 2 to pi by 2. As we know, this is the range of sin inverse x. That range of sin inverse x is also called the principal branch of sin inverse x. Similarly, this is the principal branch of cos inverse x. This is the principal branch of tan inverse x. So the values of those inverse trigonometric functions which lie in that principal branch, those values are called principal value of those inverse trigonometric functions. Cos inverse of cos y is equal to y whenever y lies in the closed interval 0 to pi. tan inverse of tan y is equal to y if y lies in the open interval minus pi by 2 to pi by 2. Okay. So similarly, you can obtain these formulae for the other three inverse trigonometric functions also. Then further, sin inverse x. Sin of sin inverse x is equal to x if x lies in the closed interval minus 1 to 1. Cos of cos inverse x is equal to x if, again here also, x lies in the closed interval minus 1 to 1. Tan of tan inverse x is equal to x if x is a real number, if x belongs to R. Okay. So here sin of sin inverse x is equal to x if x lies in the closed interval minus 1 to 1. Cos of cos inverse x is equal to x if x lies in the closed interval minus 1 to 1. Tan of tan inverse x is equal to x if x belongs to R. Okay. So now by the definition and by looking at all these things, whatever that we have studied in inverse trigonometric functions, let us solve few problems. Okay. The question is, find the principal value of the following. Firstly, sin inverse of 1 by 2. Okay. So we want to find the value of sin inverse of 1 by 2. And so here what we should have to do is find a value of theta such that sin theta is equal to 1 by 2, and we have to ensure that that theta is in the closed interval minus pi by 2 to pi by 2. So it is very obvious that sin inverse 1 by 2 is equal to pi by 6, since sin pi by 6 is equal to 1 by 2. Okay. Then what is the value of cos inverse of 1? So now you have to choose one angle theta such that cos theta is equal to 1. So cos theta, when will it become 1? As we know, cos 0 is equal to 1. Therefore, cos inverse of 1 is equal to 0, since cos 0 is equal to 1. Then tan inverse of root 3. Tan inverse of root 3. Can you tell what is the value of tan inverse root 3? Yes, you are right. It is pi by 3, because tan pi by 3 is equal to root 3. As tan 60 degree, tan pi by 3 or tan 60 degree is equal to root 3, we can say that tan inverse of root 3 is equal to pi by 3. Then I will take cosecant inverse of 2 by root 3. Cosecant inverse of 2 by root 3. Cosecant inverse of 2 by root 3 is equal to pi by 3, since cosecant pi by 3 is equal to 2 by root 3. If you don't know what is cosecant pi by 3, it's okay, because you already know what is sin pi by 3. Sin pi by 3 is root 3 by 2, so its reciprocal cosecant pi by 3 is 2 by root 3. Cosecant pi by 3 is 2 by root 3. Therefore, cosecant inverse of 2 by root 3 can be written as pi by 3. Then cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2. As we already know, cos inverse of 1 by 2 is equal to pi by 3. Now by thinking that cos inverse 1 by 2 is pi by 3, therefore cos inverse of minus 1 by 2 is equal to minus pi by 3, then you are wrong. Because cos of minus pi by 3 is equal to cos pi by 3, that is equal to 1 by 2 again. cos of minus theta is equal to cos theta itself, that will be equal to 1 by 2. So we want cos inverse of minus 1 by 2, and you know that the range of cos inverse x is closed interval 0 to pi, so you have to find an angle in that interval 0 to pi such that cos theta is equal to minus 1 by 2. So what is that angle? That angle is 2 pi by 3. Cos inverse of minus 1 by 2 is equal to 2 pi by 3, since cos 2 pi by 3 is equal to minus 1 by 2. Then cot inverse of 1. Cot inverse of 1. So here we have to find an angle theta such that cot theta is equal to 1. Cot theta, when it will be equal to 1? Cot theta will be equal to 1 when theta is equal to pi by 4. So cot inverse 1 is equal to pi by 4, since cot theta, since cot pi by 4 is equal to 1. Then another example I will choose, that is secant inverse of 2. Secant inverse of 2. Secant inverse of 2. So here we should identify an angle theta such that secant theta is equal to 2. So when secant theta is equal to 2, immediately you can take its reciprocal, cos theta, which must be equal to 1 by 2. Cos theta will be equal to 1 by 2 when theta is equal to pi by 3. So secant inverse 2 is equal to pi by 3, since secant pi by 3 is equal to 2. Okay, so now let us look at the next set of problems. Find the value of the following. Find the value of the following. First question, sin inverse of sin pi by 6. Sin inverse of sin pi by 6. So I want to find the value of this. Earlier, already I gave you one formula which says sin inverse of sin y is equal to y if y belongs to closed interval minus pi by 2 to pi by 2. Okay. Now, can we use this formula here? Yes, we can, because here also we have sin inverse of sin y in that formula, and that y, which is pi by 6 here, lies in the principal branch. So this is not a problem. Directly I can use that formula. Sin inverse of sin y is equal to y. Therefore, sin inverse of sin pi by 6 can be directly written as pi by 6. Okay. See, if you don't know that formula, even then also you can solve this. How? I'll tell you how now. Sin inverse of sin pi by 6, that's equal to sin inverse of, you know the value of sin pi by 6. Sin pi by 6 is equal to 1 by 2. Then sin inverse of 1 by 2 is equal to pi by 6. In that way, you can obtain that value. Okay. Now, let's go to the second question now. Sin inverse of sin 2 pi by 3. Suppose I want to find the value of this. Sin inverse of sin 2 pi by 3. Okay. Here, can we use the same formula? Sin inverse of sin y is equal to y. Can we use that formula? The answer is no. You cannot use that formula directly, because this formula is applicable only if y lies in the interval minus pi by 2 to pi by 2. But here, y, in place of y, we have 2 pi by 3. That 2 pi by 3 does not lie in that interval. Therefore, we cannot directly write sin inverse of sin 2 pi by 3 as 2 pi by 3. Okay. Then what else can we do? what is the other method, or how can we solve this problem? Let us see. So this sine 2 pi by 3 is there now. I can write that as sine of pi minus pi by 3. If I take LCM, 3 is the LCM here. LCM will be 3, numerator 3 pi minus pi, that will give you 2 pi by 3. So that the 2 pi by 3 can be written as pi minus pi by 3. Okay. Now sine inverse of sine pi minus pi by 3. This looks like sine pi minus theta. You have studied this in your first PUC, that sine pi minus theta is equal to sine theta, or in terms of degrees, sine 180 degree minus theta. You know that in the second quadrant sine is positive, so sine 180 minus theta is equal to sine theta. I am making use of this formula here, that is sine of pi minus pi by 3. I will write that as sine pi by 3. Okay. So now sine inverse of sine pi by 3. Let us come back to this formula. Sine inverse of sine y, this is equal to y if y lies in the interval minus pi by 2 to pi by 2. Students, please understand this here. See, in the original problem, we had sine inverse of sine 2 pi by 3. There we couldn't directly write it as 2 pi by 3 because that 2 pi by 3 does not lie in its principal branch. However, now we have reduced that problem to this form, sine inverse of sine pi by 3, and now this pi by 3 lies in its principal branch. Therefore, we can directly write sine inverse of sine pi by 3 is equal to pi by 3. Okay, let's go to the next question. The next question is sine inverse of cos pi by 9. Sine inverse of cos pi by 9. Okay. Say I would like to use this formula, sine inverse of sine y. If I want to use that formula, I have to write this cos pi by 9 in terms of sine. So how can I do that? As we already know, cos theta can be written as sine 90 minus theta, or sine pi by 2 minus theta is equal to cos theta. So that formula I would like to use. Cos pi by 9, I will write it as sine of pi by 2 minus pi by 9, which is a well-known formula which I studied in your first year. That is sine pi by 2 minus theta is equal to cos theta. So here I am writing cos pi by 9 as sine of pi by 2 minus pi by 9. Okay, take LCM and simplify this. 18 is the LCM, so numerator will be 9 pi minus 2 pi, which will give you 7 pi by 18. Okay, sine inverse of sine 7 pi by 18 we have got here. Now it's already in this form, sine inverse of sine y. The only question is whether this y lies in between minus pi by 2 to pi by 2 or not. The answer is yes, it does lie in that interval, because say pi by 2 can also be written as 9 pi by 18. Pi by 2 multiply and divide by 9, both numerator and denominator. Pi by 2 is also equal to 9 pi by 18, whereas here we have 7 pi by 18, so clearly less than pi by 2. It lies in that interval. So we can still use that formula, sine inverse of sine y is equal to y, which will give you the answer as 7 pi by 18. Okay, let us take the next question now. Sine of pi by 3 minus sine inverse of minus 1 by 2. Oh, this is what we have to find out. First of all, this pi by 3 I will keep it as base. I would like to find the value of sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2. So now I have to find an angle theta such that sin theta is equal to minus 1 by 2. Sin theta is equal to minus 1 by 2. That is possible when theta is equal to minus pi by 6. And say you might think, sir, it is also possible when the theta is equal to 7 pi by 6, but 7 pi by 6 does not lie in its principal branch. That you have to ensure. So ensure that whatever the angle theta that you take, that theta must lie in its principal branch. For sine inverse, the principal branch is minus pi by 2 to pi by 2. So for this, sin inverse of minus 1 by 2, if I take this as theta, then sin theta is equal to minus 1 by 2. I have to find an angle theta within this interval such that sin theta equal to minus 1 by 2. And that angle is minus pi by 6. As you know, sin pi by 6 is equal to 1 by 2. Then sin of minus pi by 6 is equal to minus sin pi by 6, which is equal to minus 1 by 2. So sin inverse of minus 1 by 2 can be written as minus pi by 6. So sin of pi by 3 minus of minus pi by 6, that will become plus pi by 6. Pi by 3 plus pi by 6 is equal to pi by 2, and sin pi by 2 is equal to 1. This is the answer. Next question. Cos of 2 sin inverse of minus 1. Cos of 2 sin inverse of minus 1. First, we should find the value of sin inverse of minus 1. Sin inverse of minus 1 means I want to find a sin inverse of minus 1, let it be equal to theta. Then sin theta is equal to minus 1. Sin theta will be equal to minus 1 whenever theta is equal to minus pi by 2. So again I am repeating that theta should be in this interval. So I want an angle theta such that sin theta is equal to minus 1. So that angle is nothing but minus pi by 2. So 2 into sin inverse of minus 1, sin inverse of minus 1 can be written as minus pi by 2. 2 gets cancelled, so we get cos of minus pi. Cos of minus pi is also equal to cos pi, because cos of minus theta is equal to cos theta, and the value of cos pi is minus 1. Next question. Cos inverse of cos 7 pi by 6. Okay. Cos inverse of cos 7 pi by 6. I want to find the value of this. So when I look at this, immediately the formula that comes to our mind is cos inverse of cos y is equal to y. Cos inverse of cos y is equal to y. Is it true for all values of y? No. This is true only when y belongs to closed interval 0 to pi. So closed interval 0 to pi, which is the principal branch of cos inverse x. So cos inverse of cos y is equal to y only when y lies in the closed interval 0 to pi. Okay. Cos inverse of cos 7 pi by 6. Here 7 pi by 6, does it lie in this interval? No, because 7 pi by 6 is greater than pi. Pi can also be written as 6 pi by 6. This is 7 pi by 6. So it is greater than pi. So directly we cannot write this as 7 pi by 6. Directly we cannot use this formula because the value here 7 pi by 6 does not lie in this interval. Okay, then what else can we do? 7 pi by 6, I will write it as pi plus pi by 6. Pi plus pi by 6. 7 pi by 6 is equal to pi plus pi by 6. So this looks like cos pi plus theta or cos 180 plus theta. This is in the third quadrant. Cos pi plus theta is equal to minus cos theta minus cos theta. So I will write minus cos pi by 6. Cos inverse of minus cos pi by 6. But I want cos inverse of cos pi. I want to use that formula. So what I do is, I will write minus cos pi by 6 as cos of pi minus pi by 6. See here, cos pi plus pi by 6 or cos 180 plus theta. Cos 180 plus theta is equal to minus cos theta. Here I wrote cos pi minus pi by 6. Cos 180 minus theta, that is also equal to minus cos theta. Okay. Now if you ask me, sir, whether pi plus pi by 6 is it equal to pi minus pi by 6? The answer is no, they are not equal. But cos pi plus pi by 6 is equal to cos pi minus pi by 6, because cos 180 plus theta, right here, cos 180 degree plus theta is equal to minus cos theta, and cos 180 degree minus theta is also equal to minus cos theta. Therefore, cos of pi plus pi by 6 can be replaced by cos of pi minus pi by 6. So this will give you cos inverse of cos pi minus pi by 6, which means 5 pi by 6. Cos inverse of cos y is equal to y when y lies in its principal branch. The principal branch is 0 to pi. See, now this 5 pi by 6 does lie in this interval. This 5 pi by 6 is less than pi. So it lies in that interval. Therefore, I can write cos inverse of cos 5 pi by 6 as 5 pi by 6. Let us look at the next problem. That is tan inverse of root 3 minus secant inverse of minus root 3. Okay. Tan inverse root 3 minus secant inverse of minus root 2. Tan inverse root 3. So here, let tan inverse root 3, I will take this as theta. That means tan theta is equal to root 3. Tan theta is equal to root 3 will imply that theta is equal to pi by 3. As you know, tan pi by 3 is equal to root 3. Tan pi by 3 or tan 60 degree is equal to root 3. Therefore, tan inverse of root 3 can be written as pi by 3. Then, secant inverse of minus root 2. Secant inverse of minus root 2. For what angle? You know, the principal branch of secant inverse. Principal branch of secant inverse is closed interval 0 to pi except pi by 2. Principal branch of secant inverse x is 0 to pi except pi by 2. So for this, I have to choose one angle in this interval. Okay. So I will take secant inverse minus root 2. Let it be equal to theta. This will imply, by definition, this will imply that secant theta is equal to minus root 2. Secant theta is negative, means either it is in the second quadrant or it is in the third quadrant. As you know, cos theta is negative in second and third quadrant. Therefore, secant theta, being the reciprocal of that, is negative in the second and third. So now, I cannot take I cannot go to third quadrant because that value of theta should lie in this interval 0 to pi except pi by 2. So it has to be in the second quadrant only. There is a value of theta in the second quadrant which will make secant theta as minus root 2. That angle is 3 pi by 4. If you are in confusion, you can take the reciprocal. Cos theta is equal to minus 1 by root 2. In the second quadrant, this can happen when theta is equal to 3 pi by 4. So, secant inverse of minus root 2, Okay, see, theta is equal to pi by 4, which will imply that secant inverse of minus root 2 is equal to 3 pi by 4. Now, let us come back to this and substitute here. In place of secant inverse minus root 2, I will substitute 3 pi by 4. Take LCM here. LCM of 3 and 4 is 12. So, this will become 4 pi minus 9 pi. 4 3 are 12, 3 to 3 by 9 pi, which is equal to minus 5 pi by 12. That is the value of this expression. Next question. Sin of 1 by 2 cos inverse of 1 by 2. Sin of 1 by 2 cos inverse of 1 by 2. We are asked to find the value of this expression. So for that, first we will look at the cos inverse of 1 by 2. As you already know, cos theta is equal to 1 by 2 whenever theta is equal to pi by 3, 60 degree. Cos 60 is equal to 1 by 2 or cos pi by 3 equal to 1 by 2. Therefore, cos inverse of 1 by 2 can be directly written as pi by 3. So now 1 by 2 into pi by 3 will give you pi by 6. Sin pi by 6 is equal to 1 by 2. Next question. Tan inverse of tan 3 pi by 4. Okay. We are asked to find the value of tan inverse of tan 3 pi by 4. So as soon as you see this expression, immediately one formula should come to your mind. That formula is tan inverse of tan y. Tan inverse of tan y, this is equal to y if y belongs to 0, y belongs to open interval minus pi by 2 to pi by 2. Okay. So now tan inverse of tan 3 pi by 4. Can we directly write this as 3 pi by 4? No, we cannot, because 3 pi by 4 does not lie in the open interval minus pi by 2 to pi by 2. So what else can we do? So one way is find the value of tan 3 pi by 4. Okay, which is tan 3 pi by 4. Tan 3 pi by 4 means tan 135 degree. Second quadrant pi minus pi by 4. So that tan of minus pi by 4, which will be equal to minus 1. Tan inverse of minus 1 is minus pi by 4. This is one way of solving this problem. There is another method also, that is tan inverse of tan 3 pi by 4 is equal to tan inverse of tan. This 3 pi by 4 is there now. I will write it as pi minus pi by 4. Pi minus pi by 4. This is in the second quadrant. In the second quadrant, tan is negative. So this will become tan inverse of tan pi minus theta is equal to minus tan theta. Tan pi minus theta or tan 180 degree minus theta is equal to minus tan theta. That will give you minus tan pi by 4. Tan inverse of minus tan pi by 4 can also be written as tan of minus pi by 4, because tan of minus theta is equal to minus tan theta. Now coming to this form, here tan inverse of tan y is equal to y whenever y lies in that interval. So here the value of y is minus pi by 4. Minus pi by 4 does lie in this interval. Therefore, tan inverse of tan minus pi by 4 is equal to minus pi by 4. As in comparing both the methods, we got the same value. Okay, thank you.